Massive support for a theory doesn't prove it's true. Crowds cheering a claim can feel convincing, but the roar isn't the same as real evidence. In this video, we're busting myth 10 and learning to tell hype from facts with everyday examples and plain talk. You'll see simple checks you can use right away. Where the idea came from, what real data says, and what would surprise us if the claim were false. Think of it like spotting a fashion trend or a viral meme. Lots of people can jump on board, but that doesn't mean the idea stands up to scrutiny. By the end, you'll have a practical habit that helps you separate the loud applause from the actual truth, so you don't get carried away by popularity alone. The allure of massive support. People tend to trust ideas that already have a crowd behind them. When many others seem to align with a claim, the claim feels safer to accept. This pull shows up in everyday life as social proof. A simple sense that if a lot of people think something, it must be worth considering. How it works is not mysterious. Seeing a lot of agreement makes your brain treat the idea as less risky. You notice patterns and assume there's some truth under all the noise. A practical example is a product that earns many positive reviews. It feels easier to try because the crowd is already vouching for it, like a chorus you don't have to sing alone. Another everyday moment is online chatter, where a point is echoed across comments and shares, adding weight to a claim even if one voice could have said it just as well. Massive support can push thinking in a direction that doesn't fit the facts. The crowd can drown out doubts and lull you into a quick acceptance without a careful look at the actual evidence. It creates a self-reinforcing loop. More people join because they see others joining, and the idea climbs on the back of that momentum. You see this in trends that spread through friends, fashion, or a seemingly clever explanation that keeps getting louder as more people repeat it, even if the real answer remains uncertain. To navigate this lure, slow down and test claims rather than following the swarm. Start by asking what evidence would actually prove the idea wrong. Look for sources that don't profit from the popularity of the claim. Seek out counterexamples or diverse viewpoints, not just the most vocal supporters. Try simple experiments in your own life or with reliable, plain language explanations to see if the claim holds up. When the crowd is loud, your best move is quiet, curious scrutiny. A little skepticism can be a healthy counterweight to the urge to join the chorus. Why numbers don't make truth? Popularity does not equal truth. Numbers show how many people hold a belief, not whether the belief matches reality. A crowded room can feel convincing, but the room's buzz doesn't prove the idea is true. The pull of big numbers is strong. They look like proof, and that pull can mislead. Sampling bias matters. If you only ask a tiny subset, the results will reflect that subset. Polling people in one neighborhood about a big, nationwide issue will miss how others think. Online polls often attract volunteers who care enough to click, not a random slice of society. The gap between who you asked and who exists in the real world can tilt conclusions. Correlation does not equal causation. Two things rising together isn't proof one caused the other. When it's hot, more ice cream is bought and more people go to the beach. The heat drives both, not that ice cream makes weather better or worse. If a chart links belief in a theory with how many people hold it, that doesn't prove the theory is true. It just shows popularity rising alongside it. Numbers can be manipulated or misinterpreted. Cherry-picking data means counting only the favorable cases and ignoring the rest. A diet study that tracks only people who stayed on plan can look flawless, while dropouts tell a different story. Graphs can lie with scale, making small changes look dramatic. Media frenzy can amplify a few dramatic numbers and drown out quieter ones, so the crowd feels louder than the evidence. Treat numbers as clues, not final verdicts. Ask who collected the data and why. Check how the sample was chosen and whether important data were left out. Look for other sources that confirm or challenge the claim. Remember that liking a number isn't the same as proving a claim. Numbers are useful, but they don't decide truth on their own. Evidence, falsifiability, and the scientific method. Massive support for a theory can feel persuasive, but it doesn't prove the idea true. In science, truth comes from evidence you can observe, measure, and repeat. Evidence means clues collected from experiments and careful observations that point toward an answer. Falsifiability is the idea that a claim must be testable in a way that could prove it false. If a theory says all swans are white, finding one black swan shows the idea is wrong. That simple test keeps science honest, even when a lot of people cheer for a theory. The scientific method moves from curiosity to testable ideas. You start with a careful observation, propose a guess, then look for ways to test it. Tests should make clear predictions that would fail the idea if it isn't true. Then researchers collect data, compare what happened with what was expected, and decide what it means. Repeating tests and having others try the same thing helps show results aren't a fluke. Special care is taken to reduce bias, and teams publish methods so others can replicate. Mass support can ride on charm, media spin, or simple habits rather than solid proof. People see a claim that fits what they already think, and they notice only the supporting stories. This is called confirmation bias, and it can make a good story feel like a fact. A bandwagon can pull people in even when the evidence is weak. Sometimes two things appear related but don't cause each other. That confusion between correlation and causation trips up everyday decisions, from diets to gadgets. So how should you judge a claim in daily life? Look for predictions that could be tested, not just stories that feel persuasive. See if different teams have tested the idea and got similar results. Check whether the results have been replicated and whether the evidence comes from reliable sources. Be wary of big crowds. Science thrives on careful testing, not popularity. When a claim could affect health, safety, or money, rely on robust, replicated studies and official guidelines. And keep a little humor handy. If a miracle cure shows up with a splashy chorus of believers, demand the boring but trustworthy tests. Distinguishing consensus from proof. Consensus means many people or many experts say something is likely true. Proof is a stronger thing, a direct demonstration that can be tested and repeated. That difference matters. When a theory has broad support, it can feel reliable, but broad support by itself does not erase the need for solid evidence. A common mistake is to treat a popular idea as a proven fact. In everyday life, a crowd cheering for a new gadget doesn't prove it actually works. People gather support from experience, tradition, or authority. That can be useful, yet can hide gaps. Proof requires tests that anyone can repeat with clear results. For example, if many people feel better after taking a supplement, that might be real, but we still need a fair test to rule out other causes. A simple test could compare people who take the supplement with people who do not, under the same conditions. If the only difference is the supplement and the outcome is consistently better, that's stronger evidence. Even then, proof keeps its guard up. It should apply across different groups and settings. That's how medicine, cooking, and even everyday advice earn trust. Distinguishing the two means asking practical questions. Can a claim be checked again by others? Does the claim rest on one study or many? Are there obvious biases, such as the sponsor preferring favorable results? Are there counterexamples, or does new data keep arriving? In short, proof is a moving target that can survive many tests. It isn't handed out after a single favorable report. It grows stronger as different methods, people, and situations keep producing the same result. Massive support signals caution rather than certainty. The bigger the crowd behind an idea, the more important it is to look at the actual evidence. Consensus can guide where to look next, but it does not replace careful testing. A practical approach is to separate what people believe from what data show. Treat consensus as a map, not the territory. And if you want a memorable rule of thumb, look for replication, cross-checks, and room for falsification. Then you'll separate a chorus from a conclusion that stands up to the test. Lessons from case studies: when popularity misleads. Popularity is not proof of truth. Facts matter more than how loud a claim is. Ideas catch on because they're easy to repeat. They give people a quick sense of certainty, or because they slot neatly into a familiar story. In daily life, a claim like a skincare trick that supposedly erases wrinkles can explode online, and soon everyone quotes it as fact. Yet independent tests, may show little to no real effect. The crowd's chorus is not a guarantee of accuracy. Case studies from health and wellness show this clearly. Diet fads illustrate how popularity can outrun evidence. Detox teas or cleanses become popular after testimonials from friends and influencer posts, even though many doctors say your liver and kidneys do the cleaning already. Stories travel faster than data. Controlled studies reveal a more mixed picture. Popularity can create a placebo-like effect. People feel better simply because they expect to. Social proof can mislead in science discussions. When many people adopt a belief, it feels persuasive. In labs, truth comes from repeated experiments and transparent data, not from who has the biggest crowd. This is why a big consensus today can still be wrong if the underlying studies were biased. Always look for independent replication. A loud chorus does not equal a robust conclusion. Media and online culture amplify popular theories. A catchy headline can push a claim to viral status long before scientists finish checking it. The result is people treating a popular idea as proven, while real proof remains unsettled. What helps is a habit of checking sources, looking for conflicting studies, and trusting peer-reviewed assessments. You don't have to be a science expert to ask simple questions. Who funded the claim? Has anyone tried to reproduce the result without the original sponsor? Seek evidence beyond anecdotes and give ideas time to prove themselves. Remember, a chorus can sing off-key. How to evaluate theories like a scientist. Massive support for a claim does not prove it true. In science, belief is measured by how well a claim survives tests, not by how many people rally behind it. A strong scientist looks for predictions that would fail if the idea were wrong, and then checks if those failures occur. Facts come from repeatable observations, not from popularity polls or loud consensus. First, make the claim clear and specific. A good theory makes concrete predictions that can be tested in different situations. If a theory says 10th should happen under Y conditions, you look for 10th in Z settings and see whether it shows up. If the prediction consistently fails, the theory weakens. If it passes many different tests, confidence grows. Simple questions help. What would we expect to see if this is true? And what would refute it? Falsifiability matters. A claim that cannot be tested against reality isn't a useful scientific idea. It's okay for a theory to be surprising, but there must be a way to check it. You want independent tests, ideally by researchers who didn't help design the original study. When results are repeated by different teams with different methods, that counts for more than a single flashy paper. If a finding only shows up under very specific conditions or with researchers who have a stake in the outcome, treat it with caution. Consider alternative explanations. Most real-world problems have multiple causes or competing ideas. A claim gains strength when it outperforms other explanations across diverse data. Also weigh how big the effect is and how certain the estimate is. A small, uncertain effect isn't strong evidence for a sweeping conclusion. In fact, it often means more information is needed before drawing final conclusions. Use everyday tests and simple reasoning. For example, a new health claim should be checked against well-designed trials, replication across different groups, and whether the results stay true when variables change. If a claim only works in one lab, or only when researchers fund the study, beware. If a product promises dramatic benefits with no effort or cost, question the certainty. Real-world checks matter, not just laboratory success. Update your view as new data arrive. A scientist's job isn't to defend a favorite idea, but to adjust beliefs when evidence shifts. When conflicting data appear, seek higher quality studies, larger samples, and clearer methods. Consensus can guide you, but it isn't a final judge. Truth stands up to scrutiny, and scrutiny is a crowd favorite when done right, not when it's fueled by emotion or rhetoric. A healthy skepticism paired with open data and transparent methods keeps truth from getting crowded out by cheerleaders and hype. And yes, a little humor helps. If a claim sounds too good to be true, it probably deserves another round of testing, preferably with peers watching closely. So here's the bottom line. A lot of people believing something doesn't make it true. Truth shows up in evidence you can check, and in results that can be repeated by others, not in how loud the crowd is. If a claim sounds big and popular, that's a cue to pause. What data backs it? Has anyone independent tested it? Could there be another explanation that fits the facts just as well or better? Think about everyday life, a trendy gadget, a viral rumor, or a diet everyone swears by. Just because many folks claim it works doesn't mean it actually does. If you can't verify it with clear evidence or repeatable results, it's smart to keep it on the shelf for now. You're not alone if you've ever bought into a mass belief only to find out later it wasn't the full story. If you've enjoyed this look at Myth 10, you're in the right place for more practical thinking without the jargon. Hit subscribe, give a like if you want more myth-busting with simple explanations, and drop a claim you've wondered about in the comments. We'll tackle it together. In the next videos, we'll show easy, at-home checks and a simple checklist for spotting misinformation. No lab required, just curious minds. Thanks for hanging out, and see you soon for more clear-cut thinking and a bit of humor along the way.